Now let's talk about scientific notation. This is the form of the number in scientific notation. So the different parts of it, this M part right here, sometimes you hear it called the mantissa or the coefficient, C-O-E, the coefficient. Yep, I spelled it right. And this is your base 10, okay? And then this number up here, that's your exponent. That's your power of 10. So, you know, it's much easier to write a number in this form than it is to write the number out with all those zeros, or the dot with all those zeros, and then finally the digit if that number is smaller than 1. And so the best way to learn about scientific notation is just to practice and see a few examples worked out. So let's say I have this number, 314.15, and I want to put it into scientific notation. Now, in normalized scientific notation, what I do is I take my decimal point right here and I move it so many spaces until that decimal point is right behind the first non-zero digit in my number. Okay, so here I've got my decimal point and I'm going to move it to the left 1, 2 spaces here, and then my number becomes 3.1415 times 10 to the, what number am I going to put for my exponent? Well, here I had to move my decimal 2 spaces to the left. And when you move 2 spaces to the left, you have a positive exponent. I moved it 1, 2 spaces to the left, so there's a 2 on here. So this number, 314.15, in scientific notation becomes 3.1415 times 10 to the 2. Okay. Now let's see another number. What if I had a number 0.000042? How do I put that in scientific notation? That number is smaller than 1. Well, I still want to move my decimal place until it's behind the first non-zero digit. I'm going to move it 1, 2, 3, 4 spaces to the right. And when I move my decimal to the right, I have a negative exponent on my 10. That means that that number is smaller than 1. So this number becomes 4.2 times 10 to the minus 1, 2, 3, 4, times 10 to the minus 4, okay? So normalized scientific notation means that there's only 1 digit in front of my decimal spot. Now what if you happen to see, sometimes we do this in science, 234.5 times 10 to the 2. Okay. This number is not in normalized scientific notation. Okay. And to put it in normalized scientific notation, I still have to move my decimal spot 1, 2 places to the left. So if I do that, my number becomes 2.345 times 10 to the what? Well, we already have our 2 here, and then I had to move it 2 spaces to the left, which gives me a positive plus 2 on my power of 10, my exponent. So then my number becomes 2.345 times 10 to the 2 plus 2, because I moved it, the decimal 2 spaces to the left. So that becomes 2.345 times 10 to the power of 4. Okay, now let's say we have a number like this. Let's just say we just have the number 4 million, okay? And you're like, well, how do I put that in scientific notation? I don't see a decimal spot, a decimal in this number yet. We can always place a decimal right here at the end of our number. And if I do that, I move my decimal 1, 2, 3, 4, 5, 6 to the left. So that number becomes 4 times 10 to the 6, okay? And so you're going to practice putting a bunch of numbers in their decimal notation into scientific notation. And then you might do the opposite. Take some of these numbers from scientific notation and then do the opposite, put them back into their decimal notation. So when I say decimal notation, that's the whole number written out with the zeros and the decimals and all of their digits without your times 10 to the exponent, okay? But you're going to see that it's going to be a lot easier to write some of these numbers, especially these really, really small numbers and these really, really big numbers in scientific notation instead of having to deal with all of those zeros and all those additional digits. Now, what do you do if you have numbers in scientific notation and you need to perform an operation on them? That means you need to add them or subtract them or multiply or divide them. There are some rules that we have to follow in order to perform those operations on your numbers, and we're going to talk a bit about that too. So let's say we've got this number here, 4.0 times 10 to the 6. That's the same thing as my 4 million that I just had right here, plus 2.0 times 10, times 10 to the 5. Okay, and I want to add them together. So you could get out your calculator, and if you know how to do scientific notation in your calculator, maybe this isn't so hard. But if you want to do this by hand, you cannot just say, oh, well then that's 4 plus 2, that must be 6.0 times 10 to the 6 or times 10 to the 5. That would be incorrect, okay? So that's not the correct way to do that. Because if we expand these numbers back out again, here, this is our biggest number here. Here we've got 4 million, okay? And then our 2 times 10 to the 5, that would be 200,000. Let's check. If I put a decimal place here, I go 1, 2, 3, 4, 5. Yeah, so that's 200,000 is 2 times 10 to the 5. Okay. So, you know, this is the way that you probably learned how to add when you were in elementary school. We have to do it like this, right? So our answer, I'll put those are commas, it becomes 4,200,000 or 4.2 times 10 to the 3, 4, 5, 6 times 10 to the 6, right? So you can't just add across the 4 plus the 2 in order to get your answer. So this is what it looks like if you were to put these numbers back into their decimal notation and add them up together. So the thing that you want to do if you're going to add up these numbers by hand is to put them in notation where they both have the same power of 10. Then you can go ahead and just add them across each other, okay? So let's try to do that. Let's say, so we've got, let's keep our 4 million as it is right here. And let's say that we want to put our 2.0 times 10 to the 5 into scientific notation such that it has the same exponent, the power of 6, instead of the power of 5. It will no longer be in normalized scientific notation if we do that, but that is okay. Okay? So if we want to do that, we have 2.0 times 10 to the 5. Now remember, if we have to move our decimal spot to the left, we add 1 on our exponent. If we move our decimal spot to the right, we subtract 1 from the exponent. Okay, so if I want to get my 2 times 10 to the 5 to have the same exponent as my number 4 times 10 to the 6, what I'm going to have to do is move my decimal to the left. Okay, and so if I do that, then this number becomes 0.2 times 10 to the 6. Okay, it's no longer in it's no longer in normalized scientific notation, but this number is still correct, okay? 0.2 times 10 to the 6 is the same thing as 2.0 times 10 to the 5, okay? It's just not normalized. So now, because this number now has the same power of 10 as my 4 times 10 to the 6, now I can add them together. So now I can do 4.0 times 10 to the 6 plus 0.2 times 10 to the 6, and since they both have the same exponent on each other, I can add the 4.0 to the 0.2 and get 4.2 times 10 to the 6, which is the same answer that we got up here. Okay, so usually in physics, operations like this, you're probably going to use your calculator. In astronomy, we're probably not going to be adding numbers like this together so much as we might be multiplying or dividing numbers instead. So I'm not going to have you practice doing any of these problems in a homework or a lab, but you might encounter them at some point during the course of your class with me. Now what happens when we multiply and divide numbers in scientific notation? And this, the method I'm going to show you is something that you can do whether or not you have a scientific calculator. You can always use this method. It might take you a little bit longer sometimes to do this by hand rather than punching it into a scientific calculator, but it still works. So to multiply numbers in scientific notation, we first multiply their coefficients or their mantisas, and then we add the exponent. So for example, let's say we have two numbers here, 2.5 times 10 to the 6. Okay, I'll put parentheses around it. And we're going to multiply it by, sometimes that little dot means to multiply, 2.0 times 10 to the 4. Okay, and so what we do is we multiply our two coefficients by each other. So you take 2.5 and you multiply it by 2.0, and that gives you 5.0 times 10 to the, well, to get your coefficient on the answer, you add the exponents here. So you add 6 to 4, and then your exponent becomes 10. So 2.5 times 10 to the 6 times 2.0 times 10 to the 4 gives you 5.0 times 10 to the 10. Okay, so you multiply the coefficients together, and then you add the exponents. Now, what if we divide? Let's say we took 6.4 times 10 to the 5, and we divide it by 3.2 times 10 to the 2. Okay, so we divide the coefficients by each other, and then we subtract the exponent to get our final answer. So then this looks like 6.4 divided by 3.2 times 10 to the power of, we subtract our exponents, so to the power of 5 minus 2. Okay, and so then 6.4 divided by 3.2 is 2, so that becomes 2.0 times 10 to the 5 minus 2 is 3 times 10 to the 3. Okay, and so you can always use that method regardless of if you have a scientific notation or a calculator that can handle scientific notation in order to do these calculations. And so you're going to practice a couple of these in the work below as well.